So in this new series, we are going to talk about robotics. We will be able to create all kinds of robots, like the line follow robot that follows a specific line. Also, we'll be able to control our robot car using a smartphone. And this is going to be our first tutorial. We'll talk about all of the components that you're going to need and finish up by creating some methods or functions. For example, we are going to create a method to move the car forward, or we can move it backward. Also, we need to turn it left and right. So without any further ado, let's dive right in. First of all, you need to have a microcontroller like the ESP8266, or you could use an Arduino Uno. It doesn't matter which microcontroller you have, we are going to follow the same steps. Of course, we're going to need at least 2 DC motors to be able to control the robot car, and I have used a glue gun to stick the DC motors. Now, to be able to control these two and move the robot car forward, backward, or right and left, we have to use this motor driver. It is called the L298N motor driver, and it allows us to control 2 DC motors. There is another version that allows you to control 4. Our left motor is going to be motor A, and the right one is going to be motor B. We're going to talk about the circuit schematic later on. Finally, we need a power supply, like a 9-volt battery. If you are asking how I've got the base of the robot car, actually I have bought this toy for less than $1. I think it fits well with our project. We'll be able to control it using our L298N motor driver. And here is the circuit schematic diagram. We have to connect our DC motors using these leads. The motor driver that I have seems a little bit different. They have changed the position of the leads, but it doesn't matter. This is going to be our motor A and this is our motor B. To power up our L298N motor driver, we have to connect the positive lead of the battery to the VCC. You could use a voltage between 8 and 12 volts. The GND goes to the GND. Luckily, we don't need another power supply to power up the Arduino board. We could use these two leads. We can connect the GND to the GND and this lead that outputs 5 volts to the VN. And the most important part is how to control the DC motors using our microcontroller. Basically, we have to use these 4 pins that are labeled input 1, 2, 3, and 4. We use input 1 and 2 to control the left DC motor. For example, you could hook them up to the digital pins number 4 and 5. We can control the direction of the DC motor. If we send 5 volts using the digital write command to this pin and 0 volts to the second one, our left motor rotates in a specific direction, for example forward. But if you reverse the values, which means we send 5 volts to this pin and 0 volts to the input number 1, our DC motor rotates in the opposite direction. But if you want to stop it, we have to set these 2 pins to 0 volts or 5 volts at the same time. The same principle applies for the right motor, but we are going to control it using the pins 2 and 3. In my case, I'm not going to use the Arduino Uno. I'm going to use the ESP8266. You see that we have the same connections. The only difference is the pins that we use to control the DC motors. In an ESP8266, we have pins like D0, D1 to control the left motor. Now you could stop the video and follow one of these circuit schematics. Once you finish up connecting all of the wires, we can move on to the coding part. We need to know how to control our motor A, which is our left motor, and our motor B, which is going to be our right motor. I'm using the ESP8266. We can connect it and open up the Arduino IDE. And let's start by adding the pins using int. I'm going to call the first one MA1 for motor A. I have used the digital pin D0 and add another variable and call it MA2, which is D1. For motor B, we've used the digital pins D2 and D3. I highly recommend you to use some comments. This is going to be our left motor, and these pins for our right motor. Under the setup function, we have to use these pins as outputs using pin mode that takes in the pin number, like MA1, and the output keyword. Then I'm going to copy it 3 more times and set the pin mode for MA2, as well as the other pins, MB1 and MB2. Our next step is to recognize the pin that moves the motor forward. For example, if we set this one to high and the other one to low, we're going to take a look at the DC motor. If it goes forward, this pin is going to be responsible for moving the motor forward. So let's try using digital write and give it MA1. Let's set it to high and set the other one to low. And let's upload the code after selecting the right board. For me, it's a Node MCU and the port of the USB cable. And I highly recommend you to put the robot car in a higher position because the DC motor will rotate. And there you go, our DC motor is moving forward. I highly recommend you to add a comment. Let's call this one forward pin. And the second. Now let's test our second motor, which is the MB motor, and hit upload again. In this case, our DC motor is moving in the opposite direction, which means MB1 is responsible for moving the motor backward. Make sure to add the comments to these pins because we are going to use them later on to create all of the other robot cars. Or we can reverse the values. I want to use the number 1 for moving the DC motors forward and number 2 for the opposite direction. This is going to be our forward pin. Before I finish this video, let's create the functions that will control our DC motor to move it forward, backward, left or right. Using void, let's call the first one move forward. Now we know how to control the DC motors. We are going to use digital write and set the pin MA1 to high, MA2 to low to move the motor forward. The same thing for the second motor. Let's copy it and change the names to MB1 and MB2. We can copy this method and reverse the values so that we can move the DC motors backward by setting the first pin to low and the second one to high. Of course, here we have the method move backward. Now to be able to move the robot car to the right side, we need to rotate the left motor forward and stop the right motor. Let's create this function and call it turn right. As I said, motor A is the left motor. We need to move it forward and stop the second one by using low. Last but not least, we need to move our robot car to the left side by rotating the right motor forward. Here we are going to set this to low. Finally, we need another function to stop the robot car by setting all of the pins to low. I'm using Ctrl V and change the name to stop and set all of these to low. To make sure that all of the functionalities are working, let's test it in our setup function. We are going to move our robot car forward for 2 seconds. Then we are going to stop it, move it backward. Then we are going to move it right and left. If the order is the same, that means that our functionalities are working just fine. Also, I want to add a little bit of delay at the beginning and call our first function, move forward. Then we'll wait a bit, like 2 seconds, and stop the car for 1 second. So this is just for testing. To save a little bit of time, I'm going to use Ctrl C and Ctrl V so that we can call the method move backward for 2 seconds and stop it again. I think I have forgot the semicolon at the end of these lines. Now it's time for testing, but we need to unplug the USB cable and we are going to power up the microcontroller using the L298N motor driver by connecting the GND to the GND and the 5 volts to the VN. And there you go, our car moves forward, then it stops and moves backward. After that it turns right and it turns left. That means our robot car is working just fine. Now let's put it down and test it again. The robot car is moving forward, then backward. It's gonna turn right and finally it turns left. I think that's pretty much it guys for this video. I hope you like it and I will see you in the next one.